this WAEC question on galvanometer. It says a galvanometer with a full scale deflection of 20 milliamps is converted to read 8 volts by connecting a 395 ohm resistor in series with it. Determine the internal resistance of the galvanometer. Okay, let's quickly do this. Now, when approaching questions on physics, the first thing we do is to write out the parameters given on the question. So the first parameter we'll get from here is a galvanometer with full scale deflection. So the full scale deflection current is 20 milliamps. And since it's a voltmeter that we are talking about, so it will share the same galvanometer current. So full scale deflection current is 20 milliamps hour. 20 milliamps hour. And then you convert this to its standard unit. Standard unit for current is amps, not milliamps. So this will be 20 times 10 raised to the power of minus 3 amps. So the next parameter here is converted to read 8 volts by connecting 8 volt. That 8 volts there represents the voltmeter reading. V equals to what? 8 volts. And then by connecting a resistor, the resistor connected in series with the galvanometer is what? 395 ohms in series with it. So determine the internal resistance of the galvanometer. Internal resistance, small letter r, is what we are looking for. So having been able to list out your parameters, the next thing you have to do is to find out the formula concept that is suited for the question. So now here they are talking about a galvanometer that is converted to read a voltage. And then for a galvanometer that has been converted to read a voltage, what we have done in our previous video about galvanometer conversion to voltage is that voltmeter reading equals to what? Equals to galvanometer current, you open bracket, into what? External resistor or multiplier resistor, you call it series resistor, plus what? Internal resistance of the galvanometer. So since we are looking for this small r, we are going to make small r the subject of the formula. So this will be V divided by galvanometer current. That's, you divide both sides by I subscript G. So what will be left on this side will be big R plus small r. Then for small r to stand alone, you have to take this big R to the left. And that will be what? V over I subscript G. Since this plus R here is going to be what? Minus R, equals to that. Or you can write it this way, that R equals to V over I subscript G minus R. So having done this, the next step is to substitute. So let's substitute. Our R, small letter r, will be equals to, our V is 8 divided by I subscript G. I subscript G is 20 times 10 raised power minus 3, then minus R. R is 395, which equals to 8 over 20 times 10 raised to the power of 3. This 10 raised power minus 3, you take it to the numerator, it becomes 10 raised power positive 3. Law of indices. Minus 395. So this 0 from this bottom will cancel one of the zeros here. 2 zeros will be left there. and 2 here will cancel 8 here to become 4. 4 times 100, that's 10 raised power 2 is 100. 4 times 100 will give you 400 minus 395. And when you minus that, you get what? 5 ohms. So the value of the internal resistance of the galvanometer is 5 ohms. Thank you.